Hello, everyone. My name is Stephen Cates. I'm working R&D for Repligen. And for any folks out there in R&D, you know that means you really don't have time to get anything completed, actually. So.
And my name is Madis Unt. I run Repligen operations in Estonia. It is a real country. Somewhere, far northeast in Europe, but it does exist, and Repligen does have operations there. So we do build those systems there, by the way.
But the unfortunate thing, it's bordered by Russia, so we just have to keep that in mind. Okay, enough of that. We'll take you on a little trip that we did starting forward. This is back in 2008 in a small facility in Southern California. Some people call it a garage shop. We actually started, we were asked by a large biofarm to make a single-use chrome system, or several of them actually, for a highly toxic biologic that they produced. So we started building the system using conventional components, but the difficulty was that at that time, there was not a lot of single-use technologies out there that were really usable. After building the system, we realized that there were several problems with it, and primarily which revolved around the pinch valves. The valves would either fuse the tubing closed, so the pinch valves would actually impart heat into the silicone tubing and fuse the tubing closed, or they would not close completely, so you'd have a leak of product going through it. This was really a big problem for this customer, as it posed serious contamination issues, and even product loss, up to several $1 million of product loss. So it was a big issue. So we kind of thought about it and said we owned a diaphragm valve company, so we should be able to actually design our own pinch valve. And so we proceeded to do that. The first iteration is here, and this was we had to think about the valve and make it robust, and think about the difficulties with what pinch valves do and how they pinch on the tubing. So we designed the pinch valve so that the stem was actually matched the interior radius of the tubing, and then we captured it on the outside, so you wouldn't have this typical result of the tubing expanding like the knife edge or guillotine valves of the day would do, and it would really damage the tubing seriously.
So Steve, I guess we did I don't know how many iterations of that design.
Oh, this is probably the fifth one that actually really we did a lot of testing.
100.
On it. So,
100.
well, yeah, well,
right.
the fifth of nine, hundreds of valves.
Yeah.
So the challenge really was trying to make something that was really robust, but it would actually close and seal the tubing properly without damaging the tubing in the process, and and tearing the tubing over thousands of cycles. So we did quite a bit of testing, and I can advance here. So this is a video of just testing the valve arrays. We did use vacuum as well as positive pressure to make sure that we had a good seal, and you can see we're actually at negative 15 psi here.
It does look like a garage, I have to say.
And it was a garage. We tested the 30 psi with this version of it, but eventually we were able to get up to 60 psi. The limitation here was the silicone tubing, which I'll get into later about how we address that issue.
Yeah, so we replaced the valves on the original skid that Steve had built for a customer, and as a result, the customer was really happy with our new pinch valves, because that was able to solve their everyday hassle and additional process validation steps they had to take to make the old system run. And for us, this was actually just a small sign that maybe something we are trying to do in that garage actually works, and people may want to have those valves. But this was actually just the first step, important step in our journey of trying to create single-use systems that could outperform those old school stainless steel stuff. So and there was a good reason for that. So back at the time, this was actually the single-use technology, leading technology. I mean, engineered. So basically a shelving with components randomly dropped on those shelves and interconnected by a mess of tubing and cabling. So we would actually call that an explosion in the spaghetti factory. So just things have gone a little bit sideways there. So, but yeah, I mean, Steve, what are the main problems with that kind of setup?
I mean, this type of setup, and if many of you may have seen this, you can see it has tremendous hole-up volume and difficulty to drain, and also just potential leak points at so many locations you can't count them. An operator would actually have to manipulate the tubing, holding it up over his head to actually get to a low drain point. So it was just a cumbersome mess to try to operate. And I don't know if any of you have used this type of system, and this was back in 2008 or 2007. It was really, I hate to say comical, but it was difficult to deal with.
Up there, back on the left corner, that's your CFR Part 11 data logger, by the way, on paper.
So as we were designing these systems, we partnered with a molding company, a silicone molding company, and we decided to improve on the valve designs by basically molding the sections together so we could actually put multi pinch points near the main branch, very close, so we'd eliminate dead legs and also any just reducing the hole-up volume on it. So we took this idea and applied it to doing the first generation of a chrome system. It doesn't look like this one in the back, but the first generation was like this. So we'd use the multi-valve blocks you can see.
A little bit better than the shelving,
Yeah,
I'd say.
on the bottom there, and then these are just T-blocks. This is one of our first systems, which was a isocratic system for a customer, and it's actually still in use, believe it or not. We switched it to gradient, so it's got multi-pumps on it now, but it was really well received. The customer really liked it because it was just the first generation of really doing something like that. On the insert here, as we kept iterating the valves, you can see that the valve block here that we started reducing, we did over molds, getting the pinch points very close to the main branches so you virtually have zero dead leg, and able to encapsulate the silicone tubing inside these exo housings of the stainless steel blocks. And this type of valve that's right here is what's on the skid in the back. So going forward look at this trip here, going forward in 2014, we took that idea and that design and decided to take it to the audience. So we were a small company, so the large biofarms didn't know anything about us. So we packed up a Sprinter van with a single-use skid that we designed and took it to mostly East Coast, Maryland, North Carolina, Washington, D.C.
That was the marketing back in the Sprinter van, guys.
And I have to tell you, in Washington, D.C., when I went to the FDA, security around the Pennsylvania Avenue was freaking out with a big blue van with dark windows and equipment in the back of it. We were followed for a little while, so it was pretty interesting. But we would go to various customers and roll it out in the parking lot and actually test it there, or actually do it in a conference room in a show and tell. And we received really good response from it. Most of the end users would say, if you sent me a flyer, I would have not understood it. But if it's right here in my parking lot, I can see what you're talking about, how well it's going to work. So it was really good. I didn't have gray hair there, so you can see me bent over operating the system. But it was really remarkable response from the people, and we actually got a lot of RFQs at that point in time. So for the development, we thought about the silicone tubing and the difficulties with it. So we really looked at encapsulating the silicone, and it solved a couple of problems. It allowed us to actually adjust the slope. You could actually have slope with the silicone tubing now instead of sags, and you could actually force it to drain to a low point like on a TFS system shown here. And it also allowed us to use unreinforced silicone inside this encapsulation, and silicone would actually, you could operate the system at stainless steel pressures at 4 bars, 60 PSI with no issues at all. So you're actually able to match or exceed the conventional systems, and this opened up a lot of opportunities for other processes like fire resistant activation, of course the TFF here, filling systems, everything. So this really was the next generation for us. So stepping forward to 2018, we decided really through continuous iteration, we could reduce the volume and reduce the footprint of the systems and really make them really compact and more efficient. This is a benchtop version of a quarter-inch chrome system, which we had developed, and it was, as you can see, the entire flow path is encased in stainless steel. And
it does look a little bit more like that, the unit.
yeah, so these inlet blocks, right now there's still a bubble trap on this one here. So we, after looking through the whole process, we thought we could optimize the process even more by taking the bubble trap out and just using a sterilizing filter as the bubble trap and also gradient mix point, which really, we've found that we've greatly improved homogeneity on the whole setup, and it's really quite effective. Most bubble traps are still widely used, but they're, they kind of it's almost a contradiction in terms. You have a vessel there that has 500 mLs to 2 liters holdup in it, and it really dilutes your gradient when you're trying to optimize the gradient control here. So that's just been the next iteration of our process, and this design concept is what you see in the back of the room now.
Absolutely, and it's always fun to invent and build new things and in the end blow them up. I mean, that's what we did a lot. So if you overpressurize silicon tubing and let it go with a bang, it's actually quite cool when this happened. But when the guys were doing and I was not in the company at that time, but when they were doing the trips with the Sprinter run, I guess they actually didn't want to do door-to-door chromatography selling or trying to have a Chrome system in every household in US. So they were actually more looking for interested parties, companies and individuals thinking the same way and understanding the challenges what the industry had and willing to solve those challenges together. And that's why we started to build a lot of custom systems together with those customers. And we went through majority of the downstream applications, like Steve already mentioned, chromatography, TFF, virus filtration, bulk fill systems, or buffer dilution systems. And building those custom systems actually gave us a lot of experience. So we didn't have the time and money in the beginning to immediately go to serial production and start putting out thousands of Chrome skids. So we started actually with the customs, tailored for particular customer needs, and that gave us a lot of experience and ideas how to even further develop our technologies. And at one point when we started to realize that we are using same design features what Steve and other bright guys had came up to in those custom projects again and again. So we had an ecosystem of Lego blocks. We just had to reassemble two particular custom projects, which was actually great, but we still had to figure out two challenges. The custom projects are relatively expensive, and probably most of you know that. I mean, they're expensive and time-consuming because of the design, review, design again, and then review again, and build and test, etc. So it was only affordable by a fraction of customers. But what we actually wanted to do is have our technology and inventions available for smaller companies, startups like we used to be, and so we realized the time is right to start standardizing and encapsulate our technology into the turnkey, fully automated systems, and that's when we started to develop the standard platform, and dozens of the conversations with the various customers, design iterations, testing the validated solutions have shaped those systems to what they are today. Processes that won't let you down. I mean, the performance that is outstanding, user experience, which is developed keeping in mind the operators, and the automation system that allows you to develop various recipes and customize your recipes according to your exact process needs. And we were able to package it into the nice and shiny stainless steel enclosures and make it affordable and accessible with a short period of time and a short lead time. And the best thing is, we always kept in mind the scalability. So the systems are available from 1/4 inch to 1 inch size, including the same technology, the valve blocks, the consumables, the molded consumables with the no dead legs, what Steve was talking about, and the automation platform. So that's what you can see back there in the room as well. And I encourage everyone to go and see and test the system.
Yeah. One thing I wanted to add too is people ask us why Estonia. When we traveled to Estonia to kind of meet Mattis and the team, we opened a small shop there. There was only 4 employees originally, and but it's people like Mattis and their driven ability to manufacture. There's just a culture there that's truly amazing, and it's proven us outright. So it's a great experience for us all. There's like 55 people now in the Estonia team.
Yeah.
Mattis was one of the first 4, so it was quite an interesting growth pattern.
Yeah, Estonia has, by the way, the most startup companies in Europe per capita.
Yeah.
So,
And it's
so
the
we
home
only
of
have
Skype.
1.3 million people. But okay, but considering the technology, we are by no means done. There is a lot of stuff that Steve has in his desk drawer, and what I should materialize. I'm not sure if I want to.
Yeah. We just say,
Yeah.
stay tuned for the next stuff.
Yeah.
So
So stay tuned. There is
we're
much more fun
going
stuff.
much smaller and tabletops and bench tops and bedside stuff. So we're looking forward to that.
All right, everyone.
And thank you all for being here today. Actually, it was really nice. Everyone's a little quiet after lunch, I'm sure. So it's nice to hopefully wake everybody up there. So Mattis is going to do a moonwalk.
They
we
start
held off.
serving alcohol soon.
All right. Well,
All right.
Thank you very much.
Thank you.